This is a very simple switch. It's a magnetic reed switch. Inside this glass tubing are two leaves of metal, which if there's a magnet around, they come together, close the circuit, and that's how the switch is formed. Pretty straightforward. Now, I've been fiddling around with magnetic switches for a few years now. This is a very early project of mine. It's housed in a coffee cup, and taped to the bottom of the cup is a Hall effect sensor, and then that's hooked up to an A-Tiny13 and a few other bits and pieces. And then you can use this piece of dowel with magnets at either end, and one's got light tape on it and one end's got dark tape on it. And you can activate the light with the white or light end. Oh, nearly had it. There it is. And then you can turn it off with the dark end. And kids love this when they come to stay with us. They've got a safe sort of candle, nighttime light in their room, and they can turn it on and off sort of Harry Potter style with the wand. So it's pretty cool. Just see that in the dark, actually. Oh, that's nice. Good candly action. But the reed switch can be used in a similar way. So what I've got here on a breadboard is 5 volts coming in, and then we've got a LED, and then out via this reed switch hooked up, and then down to ground. So the idea is that we should be able to activate that LED just by putting a magnet nearby the sensor, which is pretty cool. And I saw online recently a circuit that was very similar to this, but instead of just activating an LED, it activated a whole set of flashing lights, as if, for instance, you're at a level crossing. So you would have a vehicle, so I'm going to use this one here with a magnet taped on the bottom, and as it came close to the first sensor, it activated it, and then as it came close to the second sensor, it deactivated it. So I thought we'd build it, and we have seen 555 timers on the channel before, so I thought I'd try the CD40106, which is the Schmitt inverter, and build it up according to the circuit diagram online, and see if we can't get level crossing using reed switches to indicate when those crossings should activate and deactivate. Here's the circuit with the CD40106 in the middle there, and basically it's a pretty straightforward circuit. What's happening is that we've got a resistor and a capacitor combination here, and just using RC calculations, you can work out what the time delay will be for this amber warning light when it's first tripped. So I've got 47 kilo ohm resistor there and a 47 microfarad capacitor there, and so that will give us the delay. Once the delay period is finished, there's a little 100 nanofarad capacitor in there. That'll trigger the next set, which will be the flashing lights on the other side. And then finally we can cancel everything with the switch here. So let's start it off first. So there's the amber and the delay, then the flashing lights start at the crossing, and then we can kill them at the other end. Yeah, so that's pretty nice. Let's just do it one more time. So there's the amber light on, and there's the flashing at the crossing, and then we can cancel it at the other end. So that's a pretty useful circuit, not bad. That is the circuit working for this week, and we'll see you next time. Watch out for those crossings.